All right, jumping ahead a little bit, we're skipping over some of the earlier stuff in Chapter 6. What we'd like to do is solve some trig equations. So take our sort of trigonometry knowledge and use it to solve some equations. So these are going to be equations where the variables are sort of inside of a trig function. And so to solve them, we're going to be using some unit circle kind of stuff. We're going to be doing some inverse type thinking. We're not going to really be using the inverse functions specifically because these are going to be slightly more general solutions. I think the easiest way to start this is kind of just to look at an example. We're just going to kind of run through something sort of as simple as possible, and then we'll look at some algebra variations. So we're going to have something like the sine of x equals root 3 over 2. And our instructions are just like find all the solutions. So that instruction is a little bit telling, right? This isn't just like solve for x, right? I mean, in some sense it is, but there's maybe something a little bit telling there, and like, okay, so solutions like plural, like that's a little bit of an indication that this is going to be more than just like x equals pi over 2 kind of answer. First and foremost, let's just sort of think about this a little bit. We're you know, you can kind of think of this from an inverse perspective, or we can sort of use the unit circle. And we're just going to sort of figure, right, where is the sine function equal to root 3 over 2, just like what are our angles. First things first, sort of as in the inverse section, we're working with angles in radians, right? We're working with radians, and so if we look at the possible values here, we could do x is equal to what are we going to get? So it's positive, so we should have a quadrant 1 value, so that would be pi over 3, right? That's kind of quadrant 1. We can also get in quadrant 2 pi over 3. So, right, that's sort of two possible answers. So like one in each quadrant. Now the thing is, we didn't really put any kind of a restriction on how many rotations we could cover. So what we need to do is we need to account for extra rotations. In other words, like other like coterminal answers, right? So coterminal angles to pi over 3 or 2 pi over 3. These two positions, right, are unique, right? One in quadrant 1 and one in quadrant 2. Those are unique answers, and it's enough to sort of just like have those two. We're not really going to be able to relate them together. But we do need to think about, what if I added another rotation? What if I added 2 rotations? What if I went backwards 3 rotations and got like a big negative answer that ended up in the same boat? How do I sort of account for that? And so the answer is we're just going to use a very generic plus 2 pi times n. So this is going to be where like n is essentially just like any positive or negative whole number. So n could be any kind of like, right, 0, 1, 2, 3, 4, 5, 6, 7, or negative 1, negative 2, negative 10, negative 100, right, any sort of positive or negative whole number. And so times 2 pi, what that's going to get us is these initial positions, so plus 2 pi n, plus 2 pi n. So that's just going to sort of generalize these solutions a little bit. So we get kind of one quadrant 1 answer that we sort of generalize with this 2 pi n, and we get one quadrant 2 answer that we generalize with the 2 pi n. So if we're asked to find all the solutions to a particular equation, it really just amounts to this. We're sort of doing kind of once around the unit circle to find the initial positions, and we're just going to sort of add a 2 pi n to generalize it to sort of any number of rotations. It's a pretty quick, just like notational fix to help us from having to write out dozens and dozens, hundreds of angles, and when would we stop if we didn't generalize it somehow. Let's mix in a little algebra. So in theory, right, we could sort of do this type of thing just like as much as we want. But if we mix in a little bit of algebra, we can get some other stuff going. So let's say something like 2 times the cosine of x plus 1 is 0. It's like, okay. I'm sorry, negative 2 times the cosine of x plus 1 is 0. So what I want is like cosine of x is equal to some number. That's kind of the form that I want, right? I can sort of work off of that just using unit circle kind of stuff to get to an answer. That's what I'm after. So all I need to do is just do a little bit of algebra to kind of like get this together. This is pretty quick, right? We're just going to sort of add this one over. So it's like, okay, negative 2 times the cosine of x is equal to like positive 1. Then to get rid of this negative 2, I'm just going to do a division. So I end up with this like cosine of x by itself is equal to negative 1/2. What I should get then for cosine, right, is a quadrant 2 answer and a quadrant 3 answer. So where is the cosine of x equal to negative 1/2? That's going to happen for us at, so x equals, oops, or no, that would have been fine, 2 pi over 3, and we'll just sort of say plus 2 pi n, or what would our next one be, 4 pi over 3 plus 2 pi n. So I get a quadrant 2 angle, which was this 2 pi over 3, and a quadrant 3, which was 4 pi over 3. Quadrant 1 and quadrant 4, my cosine is positive, so those aren't going to give me the solutions I'm after. Right? I need essentially one each from those quadrants. What if I got a little bit more clever? How could I do that? More clever, more sneaky than that? What if I did something like 3 times sine, 3 times sine squared of x minus 4 equals 0. So what if I even start to throw some like exponents into the mix? What can I do? Can I still like solve this? Are there ways to do it? I still sort of need to get just down to like 1 sine of x. So this is going to be, okay, we're going to add this 4 over, right? So that's like 3 times sine squared is like positive 4. Divide by the 3. Oh, whoops, my bad. I messed this up. Whoops. 3 stars for you if you can figure out what my error was. I want to flip the roles here of the 4 and the 3. Let's reboot. Let's try it again. 4 times sine squared of x is going to be positive 3. If I divide by 4, so what I'm heading towards is the not particularly fantastic trig value. So sine squared of x equals 3/4. So, okay, that's good, I guess. 3/4 is definitely not really a trig value that we're used to, but this is a sine squared, right? This is not just like sine of x. How do I get rid of squared value? Well, we'll take a root of both sides, and so when I do that, I'll get down to a regular sine of x, and I'm going to get the positive and negative versions of the root of 3/4. So like that is also still not really a great trig value. However, if I start to break this up, this would be root 3 over root of 4, which would be positive or negative root 3 over 2. So lo and behold, in a somewhat non-obvious way, we end up with a semi-decent trig value, right? So sine of x could be positive or negative root 3 over 2. So we're getting here, right, in some sense, 2 different answers. So sine of x is like root 3 over 2, or sine of x is like negative root 3 over 2. And then each of those are going to give us two different answers for x. So the x will be, and then generalized, right? So this is going to happen at what? Pi over 3 again. Really loving the pi over 3's here. Pi over 3 plus 2 pi n, right? The other positive would be 2 pi over 3 plus 2 pi n. And then for my negatives, I'll get quadrant 3 and quadrant 4. So that'll be 4 pi over 3 plus 2 pi n. We're in quadrant 4, 5 pi over 3 plus 2 pi n. So this is like kind of, it's not quite a factoring thing. You could sort of almost try to do this as a quadratic like type thing, but we can kind of get there just by doing a pretty quick sort of rearranging and like taking a root. If you end up with something that sort of is like pre-factored, you can do these same kind of solution techniques. Let's just do sort of one more kind of quick. So pre-factored, so this is kind of like some of those polynomials we were doing. So maybe I have something like the cosine of x plus 1 times, I don't know, tangent of x, like minus the root of 3, equals 0. So if I get two pieces that are sort of like pre-factored, this is really just like two short equations, right? These are both sort of equal to 0. So I'm just going to get, right, cosine of x plus 1 is 0. Well, if we shift this over, right, that means the cosine of x would be equal to negative 1. That only happens the once, I guess, right? That's going to happen just at x equals pi. We're in sort of find all the answers scenario, right? So this would be plus 2 pi n. Tangent of x of minus root 3 equals 0. So that's just going to be a matter of sort of adding this root 3 to both sides. So tangent of x would equal this like root 3. That's essentially, right, root 3 over 1. This should be kind of a y over x answer in our unit circle. So if we sort of reference our unit circle, we're being a little bit fast and loose with like what our x like variable is representing here. We sort of have the x coordinate, we have a kind of x the value here, x the variable. In any event, what we're going to get in this case, so where is our tangent? So that means the y coordinate's got to be root 3, syncs up with the sine value, so that's going to be yet again pi over 3 plus 2 pi n, and then because it's tangent, this is also going to happen in quadrant 3, right, where we're going to be positive. So that would be 4 pi over 3 plus 2 pi n. So the final answer would include all of those angles together. We're only getting really one here because this, if cosine is sort of positive negative 1, that only is an answer that shows up once going around the circle. Tangent, right, working with that, we've got one of these sort of awkward sort of root 3 values, but hopefully we've got some sort of table where we've kind of built these up a little bit more. And we can sort of reference them and get those answers pretty quick. So to get us started, that's the basics of it, right? So we can do a little bit of algebra stuff. We can sort of just, you know, do shorter ones and just sort of get the answer directly. So kind of coming off the unit circle and going from there.